In today's class, we will be discussing about minimization of DFA. Before moving into the topic, we will discuss the difference between NFA and DFA. There are two types of finite automata, that is NFA and DFA. And DFA means deterministic finite automata, and NFA means non-deterministic finite automata. Now consider this diagram. Let it be having two states. This is the initial state and this is the final state. Let it be named as A and B. Now we will have two inputs, that is 0 and 1. Okay, now consider, I'll draw the transactions. Okay, let it be 0, 1 and 0 and 1. Now this is called as DFA, because by using input 0 from state A, we are going to state A itself, that is self loop. By using one input, you are going to only one state, right? If we use same input and go to multiple state, means that is called as NFA. Okay, consider this example, the same example. Let it be A and B. This is initial state and this is final state. Okay, now this is 0, this is 1. Okay, and this is 1 and this is 0. This is DFA. Now if I use 0 here, by using input 0 on A, I can go to two different states, right? That is there is self loop that goes to A, and there is another input 0 where I can move from A to B. So this is called as NFA. By using single input from one state, I can go to multiple states. This is called as NFA. Okay, now coming into minimization of DFA, what we are going to do is there will be a number of states. From that, we need to reduce the number of states. Let it be 5, means we have to minimize at least to 4. Okay, we have to at least minimize one state. Okay, now before minimizing the given states, we should know whether the structure is DFA or not. Okay, in some they may provide NFA and ask you to convert it to DFA. In that cases, what we need to do is we need to convert NFA to DFA first, and after converting NFA to DFA, we can minimize. Okay, we have to check the sum first. Okay, these are the steps. First thing is we need to draw a table for all pairs of states, that is P comma Q. Second point is mark X where all pairs, where P belongs to F and Q doesn't belong to F. F means final state. Okay, I will explain while explaining the sum. Okay, if there are any unmarked pairs P comma Q such that transition of P comma X comma transition of Q comma X is marked, then P comma Q where X is an input symbol. Repeat this until no more marking can be done. Combine all the unmarked pairs and make them a single stated minimized DFA. Okay, I will explain with an example. Now consider this diagram. Here we are going to minimize the given DFA. The method we are going to use is called as table filling method, and we are going to use Myhill-Nerod theorem. Question can be asked by using Myhill-Nerod theorem or table filling method. Okay, now consider the given question. Now we need to check whether the diagram is NFA or DFA. If it is DFA, means we can directly minimize, whereas if it is NFA, means we need to convert NFA to DFA and we have to minimize. Okay, now check. From A we are going like this. Okay, input 1, A comma 0 goes only to B, A comma 1 goes only to C, B comma 0 goes to B only, B comma 1 goes to D. Likewise C comma 0 goes to B, C comma 1 goes to C alone, and D comma 0 goes to B and D comma 1 goes to E. E comma 0 goes to B and E comma C goes to 1. So therefore the given structure is DFA. We can confirm that the given structure is DFA. First thing is they have given the transition diagram. We need to draw transition table like this. Okay, now consider based on the given diagram we have drawn the transition table. Okay, now this table should be filled. That is while writing this side, we need to, there are 5 states. Okay, we need to take only the first 4 states, that is A, B, C, D alone. Okay, whereas while writing like this we need to skip the first state and we have to write all the states. Okay, so diagram will be there will be 4 states here and 4 states here. Okay, we need to find the value for all these cells. Okay, that is for this cell it is called as a comma e, whereas this cell is called as b comma e. Likewise we have different cell names. Okay, from this what we need to do is we need to consider um, from A and E, this cell is the combination of A and E, right? We need to put X if any one of the given state is X is final. Okay, now consider here A comma E is A is non-final and A is final, so this state we can mark it as X by default. This is the first step. Consider B comma E, likewise B is non-final and E is final, so we can mark X. Likewise we need to consider all these cells. Now consider B comma C. B is non-final and C is non-final, so we should not mark here. Okay, likewise which are the states that we can mark directly E? Now consider which are the states that we can mark X. I'll use a different color now. A comma E is A is non-final and E is final, so we can mark X here. Likewise B comma E, B is non-final and E is final, so we can mark X here. C comma E is C is non-final and E is final, so we can mark X here. Likewise regarding D comma E, we can mark X here, right? Regarding A comma D, A and D are non-final, B and D are non-final, C and D are non-final, all those things are not final, right? Now what we need to do is we need to try to make all these cells as X. Okay, now consider A comma D. Let the cells be A comma D. Okay, now A comma 0, D comma 0, A comma 1 and D comma 1. Now from the transition table we can write the values here, right? A comma 0 goes to B, right? D comma 0 goes to B, A comma 1 goes to C and D comma 1 goes to E, right? Whenever we need to consider this now. Okay, the answer is B comma B. There is no such cell named as B comma B, right? So we can leave this. Next is C comma E. C comma E, there is cell. In C comma E we have marked already as X, right? So since C comma E is X, we need to mark A comma D as X here, so we will mark X here. Okay, next one is, hope you guys understood. Next one is B comma D. Likewise we got to draw for all these cells, right? B comma 0, D comma 0. Next B comma 1 and then D comma 1, right? B comma 0 goes to B, D comma 0 goes to B. There is no such cell, so we can skip this. B comma 1 is D and D comma 1 is C. So you have to check D comma E or E comma D. There will be only one cell. Okay, so D comma E is X. So what we can do, since B comma 1 is equal to D and D comma 1 is equal to E, we will check these cells. D comma E is X, so we can mark B comma D as X here. Okay, now we have to check for other cells also. Likewise you have to check. Okay, we'll check one by one. Now next cell is C comma D. C comma 0 is B and C comma D comma 0 is B. These two cells are similar, there is no such cell, we can skip this. C comma 1 is C and D comma 1 is E. So C comma E. C comma E is already marked as X, so we will mark X here. Okay, likewise you got to check for other three cells. Okay, now consider A comma C. B, there is no such cell. A comma 1 is C and C comma 1 is C, so we will not be getting the answer as, since it is same cells we will try to skip. Now consider a comma 0, c comma 0. A comma 0 is b and c comma 0 is also b. There is no such cell, so we can skip. Regarding a comma 1, the answer is c, and c comma 1, the answer is c. There is no such cell, so we will not mark this cell. Okay. Likewise, you got to go to other cell. Next, b comma c. What is b comma c? B comma c is, sorry, b comma 0. B comma 0 and c comma 0 we got to check. B comma 0 is answer is b, and c comma 0 answer is b. So there is no such cell. B comma 1, the answer is d, and b comma, sorry, c comma 1, the answer is c. C comma d. What about c comma d? It is already marked as x, right? So we can mark b comma c as x. There is only one cell remaining, that is a comma b. A comma b, that is a comma 0 is b, and a comma b comma 0 is b. A comma 1 is b comma 1. A comma 1 is c, and b comma 1 is d. So c comma d is already marked as x, so we can mark x, right? After we have completed one iteration, right? After one iteration, only one cell is remaining, that is not marked, right? In the second iteration, we should try to mark this cell as x. Okay, if we get the same answer as non-marked, we can skip. Okay, for the future problems I'm saying, we need to check for n iterations. Whenever we get the same answer for two repeated iterations, we can skip. If there is change in one iteration, now we got to try again and again. Okay, hope you guys understood. Now we need to try again. That is, first iteration completed, we are going for second iteration, that is a comma c. A comma c means b comma b, there is no such cell, and a comma 1 is c, and b c comma 1 is c, there is no such cell. After moving into a number of iterations, we will not be getting the answer, since we are getting the same states as answers, right? So this will not be marked again. Now these are the things that we have did already. Okay, all the states are marked except a comma c, right? So the meaning for this is, whenever we are getting non-marked states, those states are said to be equal. That is the meaning. Okay, now only one state is non-marked, that is a comma c. What we will be concluding is a and c are equal. We need to check the answer with the given question also, right? So here what we are going to declare is a comma c is non-marked, so it is minimized, like that, or we can say that as a and c are equal. Now we need to check the given answer, right? Now what we have concluded is a comma c is equal, like that we have mentioned, right? Now consider a comma 0 goes to b, and a comma 1 goes to a, no problem. B comma 0 goes to b, and b comma 1 goes to d, right? Now coming into c part, what we are going to do is, we have mentioned as a and c are equal. Now we need to check the value of c with the inputs 0 and 1. That is c comma 0, where it goes, you can check. C comma 0 goes to, from the above diagram, c comma 0 goes to b, right? The answer is already b here, right? Whereas c comma 1 goes to c itself. What we have mentioned, c and a are equal, so we can simply mark a instead of c. Hope you guys understood, right? Now coming to this, c comma 0 goes to b, right? A comma 0 also goes to b, so there is no problem. Since these two states are equal, since the answer is same, we can say that a and c are equal. Whereas a comma 1 goes to c, and c comma 1 goes to c. What we have mentioned is a comma c are equal. So instead of c, what we are going to do? We are going to take this as a here. Okay. Now d comma 0, all these things remain same. Now what we are going to do is, we need to skip this state. Since a and c are equal, we need to skip this state, and we are going to draw the diagram again. That is, we can draw as a is b, and instead of c we have marked as, since they are equal, we have already given it as a, so we should not write c here, and then d and e. Now a comma 0 goes to b, a comma 1 goes to a. Next, b comma 0 goes to b, and b comma 1 goes to d, and d comma 0 goes to b, and d comma 1 goes to e, e comma 1 goes to 0, and e comma 1 goes to a, right? Hope you guys understood this. Now only thing we need to understand is, whenever we are minimizing, the first condition is we should check whether the given diagram is DFA. Second condition is uh, always the answer we are getting, consider we have a problem with A, B, C, D which are non-final, and E and F which are final. Okay, now after completing the minimization, we can say that A can be equal to B, or A can be equal to C, A can be equal to D, or B can be equal to D, and C can be equal to D. Since they are non-final, they can be equal amongst themselves. Likewise, E and F, they can be equal among themselves. A and E cannot be equal. Since A is non-final and E is final, we cannot equalize these two terms, these two states. Okay, we have to equalize amongst them only, that is non-final and final states only. This should be understood. Consider this question. Q1 is initial state, let it be Q2 is there, Q3 is there, and Q4 is there, let it be. Okay, and there is Q5 also, let it be. Okay, now Q1 comma 0 goes to here, 1 and 0. Let the transactions be. What we are going to do here is, we have three non-final combinations, that is Q0, Q1, Q2, and Q4 and Q5. Let it be Q1, Q2, Q3. Sorry. Now the equalization should be done between these three alone, that is Q1, Q2, Q3 alone, and it can be done in between Q4 and Q5. This cannot be equal to this, and this cannot be equal to this. That we should make sure that always non-final states are equal to non-final states, and final state is equal to final state. Okay, that's all regarding minimization of DFA.